Number one, on your test, it is worth 10 points, like I told you before. This is just a general rational equation. We're going to graph it. And these are the things that we're going to fill out if they apply. So first of all, let's go with vertical asymptotes. I know that if I set the denominator equal to 0, I can find the vertical asymptote. So there's a couple ways to do that. I could set it equal to 0 and solve, but I think it's easier, and I think you guys all have the ability to quickly factor that into x plus 3 and x minus 3. And when you set that equal to 0, we can see one of the solutions is x equals -3, and the other is x equals +3. When you write in the answer for vertical asymptotes, it cannot just be the value such as -3 or +3. It has to start with x equals. So a common mistake I see students make is they get the right number, but they forget to put x equals, or they accidentally put y equals in front. Vertical asymptotes always say x equals first. So I'm going to take my highlighter, I'm going to go over to -3 and +3. I'm going to make dotted lines going through the x-intercept of 3 and -3. You're going to notice later when we actually graph this on a graphing calculator that those asymptotes are invisible on a graphing calculator. Horizontal asymptote. Because the degree on top is equal to the degree on the bottom, we take the leading coefficient of the top and we divide it by the leading coefficient of the bottom. So -2 divided by 1 is -2. That means the horizontal asymptote is y equals -2. I'm going to go over to y equals -2, and I'm going to graph the horizontal asymptote. There is no slant asymptote. We'll learn about that on the back page, and we'll learn when that occurs. In this general rational equations form, we can determine the real roots, also known as x-intercepts, by taking the numerator and setting it equal to 0 and solving. So when I solve for x, first I divide by -2. So x squared equals 0. And when I square root both sides, normally we would say there's 2 answers, but we know that the square root of 0 can only give us one answer of 0. So x equals 0 is the x-intercept, or also known as the real root. Now before we do domain and range, we're going to grab the graphing calculator, do 2nd plus 7, 1, 2, please. Go to y equals. Okay, we're going to start with the parenthesis. When I plug in the first numerical value of -2, it's not subtract 2, the negative sign is below the 3. -2x squared in parentheses, divided by parentheses x squared minus 9. Okay, then graph it. And as you can see, the asymptotes are invisible. So we can see that the horizontal asymptote of -2 and y equals 3 and x equals -3 and x equals +3. They're invisible. But this gives us an idea of what this shape is going to look like. So we're going to come over here. As it goes up, it gets closer and closer to the vertical asymptotes. And the same on the left and right down below. Okay, the domain. There's no restriction how far it goes to the left, so it comes from, bless you, it comes from -infinity, it keeps going, it keeps going, it keeps going, and then it hits this imaginary wall, which has a value of -3, and it doesn't touch it, it stops it. That's why it is a parenthesis, because it doesn't touch it. And it jumps over this wall and it starts again. And it goes from -3, and it keeps going until it hits the next wall, the vertical wall of +3. Does not touch it. Jumps it over it again, and it goes from +3, and there's no limit how far it goes to the right. The range. This is often one that students miss on this problem. And before I write it down, do you agree these arrows say it goes down with no limitations? But here's where it's confusing. Okay, it comes from down below, -infinity, and it keeps going until it hits this imaginary wall. But when it jumps over it, it doesn't start. Do you see this like dead zone where there's no graph? What y value does it actually start at again? 0. Okay, so here we go. Comes from negative infinity and it goes up to this first wall of -2. Then it jumps over it but doesn't start again right away. It starts at y equals 0. Do you agree it's touching the y value, y equals 0? So we're going to put a bracket at 0. And there's no limitation how high it goes, positive infinity. As x goes to the left, so as I'm going to the left here, does it continue to go up with no restrictions? Does it continue to go down, or does it get closer and closer to one y value? That is the case, and it's getting closer and closer to the y value of -2. Same thing as I go to the right, it's getting closer and closer to the y value of -2.